Hello students, today we are going to see the some topics regarding the generating set, span and basis. So first we'll see what is generating set. So when it comes to the exam, you have to write this particular definition, and you shouldn't change any words in it, because the definitions are very important and you cannot frame your own definitions. So that is it, and we will dissect what is generating set now. Now consider a set of vector space V and set vector A, where it has all the vectors from x1 to xk, and which is a which belongs to V. If every vector V belongs to V can be expressed as a linear combination of x1 to xk, A is called the generating set. So what does it mean? So suppose you have a generating set, say vector space is a collection of vectors where every vector in that space can be created by combining the vectors in the set in some way or the other way. Suppose you have the example, say A is a set and you have 1, 0 and 0, 1. These vectors form a generating set of entire two-dimensional space, because any vector in that space can be created by combining these vectors. Say for instance, suppose you have to create the vector, say 2, 3. This is a vector you want to create, 2, 3. So how will you achieve by the set? So you will multiply 2 into 0, 1 and 3 into 1, 1, 0 and 3 into 0, 1. So what the answer you will get is 2, 3. So from the set A you can create the vector 2, 3. So that is what the generating set means. It is nothing but, if I say in simplified form, a collection of vectors that can be combined to make every vector in the space. So the next topic is about the span. So the definition is the set of all linear combinations of vectors in A is called the span, and it is denoted as V. It is equal to span of A. So I can say that the span of set of vectors is all the possible vectors that you can create by combining those vectors in different ways. It's like so it's nothing but combining the vectors in different ways. So I'm just writing the points in different ways. So what I can say that it's like the space that all the combination of the vectors fill up. So without any delay, let's take one example. So what is so the example will be like this. So let me take a set of vectors, say t is equal to with 1, 1 and 2, 2, which is in R square, and the span of t in the set of all possible linear combination of these vectors. So t is nothing but is a set of all possible linear combination of these vectors. Okay, so any vector, say a comma b, let me write any vector, say a comma b in R square can be expressed as say a into 1, 1 plus b into 2, 2. Okay, which implies that it is, let us multiply, it is a comma a plus 2b comma 2b, which is nothing but you get a plus 2b comma a plus 2b. So this means that every vector in R square can be created by scaling and adding the vectors, that is 1, 1 and 2, 2. Therefore the span of t is nothing but the line passing through the origin and the point 1, 1, as it represents all the vectors that can be formed by scaling and adding these two vectors. So if I draw the graph, it is nothing but, say, the point 0, 0, 2, the point, say, 1, 1. So 1, 1. So if I try to tell or sum it up, so generating set and span, so what does actually mean? If I try to take a real world scenario, so generating set you can and span you can, so generating set you can actually compare it to the ingredients, and so I can say generating set provides the ingredients to create every vector in the space. And if I represent span as a dish, then span represent all the vectors that you can make from those ingredients. So I hope you understood this. That is about the span. So the last topic is basis. So basis, the definition is like this: consider a vector v and a belongs to v. A generating set a of v is called minimal if there exists no smaller set and a belongs to b that spans v. Every linearly independent generating set of v is called minimal and is called a basis of v. It is little bit difficult to understand with the definition, and it is very lengthier. So let us take one example. Say b is a say generating set, and b is equal to say 1 comma 0 and 0 comma v 0 comma 1. These vectors are linearly independent, meaning neither can be expressed as a scalar multiple or the other. Additionally, any vector in R square can be expressed as a unique linear combination of these basis vector. Suppose you want to create this vector, say 3 comma 4. How will you create that? You'll just multiply 3 with 1 comma 0 and 4 with 0 comma 1. So it is nothing but 3 comma 0 plus 0 comma 4 into 0 comma 4 0 comma 4, which is nothing but 3 comma 4. So you are able to generate 3 comma 4 from the set say b. Okay, so therefore I can conclude that the set b 1 comma 0 0 comma 1 forms a basis for R square. It is a minimal generating set because if I remove either vector would result in a set that does not span in R square, right? Does not span for R square and is linearly independent. Any vector if I remove from the b, I cannot generate any the set. So more example we'll see in the more coming videos. So stay tuned for it. Thank you.